सत श्री अकाल बेटा जी। यंग्स एक्सपेरिमेंट को समझने के लिए कुछ टेक्निकल टर्म्स हैं, वो हमें समझ आ जानी चाहिए। थोड़ा सा सेटअप समझने में हमें आसान होगा। तो सबसे पहले तो यहाँ पर आप देख लीजिए कि यहाँ पर हम एक लेजर शाइन करते हैं और उनके वेव फ्रंट्स की क्रेस्ट जो है वो यहाँ पर मैंने दिखा रखे हैं। तो इस तरह से वेव जो होती है, बराबर वेवलेंथ बनाने की ट्राई कर रहा हूँ, गैप दोनों का सेम रखने की कोशिश है। तो इनके बीच में जो क्रेस्ट के बीच में डिफरेंस होता है, दैट इज व्हाट वी कॉल लेंथ ऑफ वेव, यानी कि वेव का एक स्टेप। ये आपको टॉप पार्ट दिख रहा है। अगर इसका आपको साइड भी देखना हो तो वेव कुछ इस तरह से जा रही है। यहाँ पर अगर मैं बनाऊं तो ये इसके क्रेस्ट हैं, यानी कि ये टॉप पार्ट होंगे तीनों, और इसके बीच में आपको मिल जाएगा ट्रफ। इस तरह से कुछ हमारी वेव है। मेरा अच्छा नहीं बन रहा है, राइट। और ये यहाँ तक ट्रफ होगा, राइट, एक लेंथ है। तो इस तरह से हमारी कुछ वेव है। और क्योंकि हमारा देखने का तरीका जो है वो चेंज हो रहा है, तो हमें यहाँ पे टॉप पार्ट ही दिख रहे हैं सारे। यहाँ पे पॉइंट्स जो हैं वो फेज में है, राइट। बट इस तरह से हम कुछ समझ सकते हैं। तो दीज आर द टॉप पार्ट्स एंड द डिफरेंस बिटवीन टू, डिस्टेंस बिटवीन टू क्रेस्ट इज अ वेवलेंथ। तो यहाँ पर ये वेवलेंथ हमें दिख रही है। अब ये वेव के साथ क्या होने वाला है, आगे आगे हमें ये जो लेजर से लाइट फेंक रहे हैं इसके सामने स्लिट आ जाने हैं। तो हम स्लिट बना देते हैं यहाँ पर। स्लिट बनाने का सिंपल, एक सिंपल लाइन लीजिए, फिर बीच में आप रबर से मिटा सकते हैं। बट हम सिंपलिसिटी के लिए क्या डॉट बना देते हैं, उनको बहुत ही फाइन बता देते हैं कि बहुत छोटे गैप हैं वो, सीधे यहाँ पे डॉट। मैं रबर से नहीं मिटाऊंगा और यहाँ पर इस तरह से स्लिट दिखा दूंगा। दैट इज व्हाट इट इज, सो स्मॉल दैट इट इज अपीयरिंग अस टू अस लाइक अ डॉट। नाउ अब ये आगे जाते हैं, यहाँ से टकराएंगे, बाकी सब कैंसिल हो जाएगा, बट लाइट विल पास थ्रू विल विद दिस स्लिट, right? So now what will happen? Let's see. So we have a screen here now where we can record, we can make the observation of the interference pattern of these two waves. And now this is the screen. This is the screen, yeah, where we are recording. And these slits, okay, the distance between them is denoted by D, small letter D, small letter D. The distance between these slits and the screen is denoted by again a D, but this time capital one. So the capital letter D is the distance between these two. Now, what will happen? We will see a pattern here. So I'm just drawing like how we will see. So you will not get two spots here. You will get at the center first, you will get some bright spot. And we don't call them bright spot. We have a fancy name for them and we call them fringe. So this is a bright fringe which you are getting. Bright fringe. So instead of calling them a spot, dark spot or bright spot, we are calling them a fringe. So what will happen afterwards? There will be no light. There will be destructive interference. So now I'm just representing that with my black color. So remember that it is not like there is some black color there. It is like absence of light. There is no light going there. We are getting a destructive interference there. So that's why we are getting this dark fringe now. Now what will happen next? You know, it will go on repeat this pattern. But here, remember, the next fringe will not will be, not as bright at this one. Okay, so the brightness will reduce as we go from the center to the right or left. Okay, well, what will happen this way? It is symmetric. It will be symmetrical this way and this way. So we will get the dark fringe again. This and this a pattern will continue. Okay, this pattern will continue. So next will be after dark again the bright fringe will appear, and this will go on and we can see the pattern of this setup. So the setup, it will depend how this will look like. It will depend on what is the distance between them, what is the distance between the slit, and what is the wavelength which you are using, which laser you are using here to for the waves to interfere. So it will depend on all these factors. Now let us understand in a simple word like why we are getting constructive interference at the center. Let's see, one wave goes from here. I'm not drawing those circles and then telling you. I'm just drawing like, let's see how much path they cover. Okay, so if you see by symmetry, if they want to reach this center, they both need to cover the same distance, right? There is no path difference between them, right? They don't have to cover different paths. So that is why what will happen is when the wave is reaching from here and from here, they are from the same wavelength. The source is same, the laser was same. These lasers were not different lasers like laser A or laser B. They were coming from the same source, so the wavelengths will be the same. So the same wavelength will cover this distance and the same wavelength will cover this distance. What will happen? So this can happen roughly if you want to understand. Let's say it goes like 1, 2, 1, 2 and reach here. Now what about the other also has to cover the same distance because this point is at the center. So this wave, this distance is also same to this distance. So this will also do 1, 2, 1, 2. So can you observe they're reaching like trough and trough are matching and the crest and crest is also matching. That is why we are getting constructive interference here. So this is another way of understanding this. We can draw circles as we did, with compass, and then we understand like, we will get all the points where crest and trough are matching. But now the path difference also makes us understand why the constructive interference is happening. So if you want to understand in a simple diagram. So it'll be like if like one, two, one wave is like that, and other waves is covering the same distance, right? So it is also the same wavelength. So of course, when they'll be lined up at the same point, right? Same path they need to cover, right? What is the path difference? I will say zero. There is no path difference, right? Zero path difference. So if that is the case, their crest will match the crest, trough will match the trough everywhere, right? So that is why we are getting constructive interference at the center. This center spot is maximum brightness, and we give a special name to this. We call this central maxima, central maxima. Because as you see, I have drawn this with the same brightness. No, it will be little less brighter. This will be the most brightest point at the center. Okay, so we got it. Here the path difference was zero. So the wave aligned here and properly, and they did constructive interference. Now answer me, sir, this. Why is this? What is the case here? So let us draw another diagram and understand what is happening to the next fringe to the central maxima. Now see the paths that I will cover from this slit and this slit to this point. So we are getting constructive interference here. One ray will reach here like this, and one ray will reach here like this. Both their paths are not same. They are covering different distance. If you see, this length is more, right? And this length is less, but still we are getting constructive interference. The answer to this is because the path difference has some logic. The path difference is of one wavelength here. Still you will get constructive interference. How? Let's see. So let's say it covers this distance by 2 because it is shorter. So it just cover 1 and 2, it reaches here, right? But this is a longer path, but the difference is of 1 lambda. Means if it is 2 lambda, this is 3 lambda. So it can happen like that. 1, 2, and 3. So the difference, the path difference, because wavelength was same, the path difference was of 1 lambda here. I can say what the path difference is 0 lambda here. So that is why we are getting again the constructive interference. Understand in a simple picture here. Like if it is going straight, if I put a wave like this, okay, and put another wave, which is let's say starting from here. So can I say that crest are not matching? They are still matching, right? But there is a path difference. Okay, they're covering different distances. Less distances this wave is covering, and this is covering more. But when they are meeting, their crest and trough are still aligning because the difference is of 1 lambda here, right? One wavelength. And now this can continue. We can keep the distance of 2 lambda, right? 2 lambda. Still, this will work. And that is why after this, we will get a dark fringe because these colors alternate. And again, we will get the brighter spot. Not as bright as the previous one, but yes. So how much the difference this line and this line will make at that time? That will make a difference of 2 lambda. So this pattern will continue on the other side of central maxima too. So this will be 1 lambda again. So this will be 2 lambda, right? Like that. So the same, that is why we are getting this kind of pattern. Let me complete this. So this is the dark again, and this is again the brighter. So this sense will be because due to symmetry, we are getting these kind of patterns. Now we understood what is the reason of getting them constructive interference. Now let's do the second part. Can you tell me then, sir, how this destructive is happening? So we understood if the integer multiple we are getting of lambda, we are getting constructive interferences, 0, 1 lambda, 2 lambda, like that, and we are getting the constructive interferences. What about the destructive one? So this way it is fun, right? We don't have to draw those circles, and we can understand just by observing how much path the ray or the light should take to reach that point, and that is how it will combine. So now let's consider this point. So if you see this point here and this point, so this is the destructive, that I'm going to the darker spot where we are not getting any light. So what will be the logic of that? We know that the path difference now, so there is a path difference. It is not, the lengths are not same. These lengths are not same, but they are meeting as such so that their crest are aligning now with the troughs. So this can be the case. So like one wave, let me put a red wave this time. So it will be like 1 and 2, say. Okay, so this is the shorter path, so it reaches 1 and 2, right? So this is a longer path, so it will say 1, 2, and this. So this part, if you see, the trough is meeting the crest, right? The crest is meeting the trough. So that is why we are getting no light here. So if you understand, if you want to understand in the straight line, you can understand like this. So this is one, like one, okay, like this. One way is going like that, and other is going like that from here, right? The path difference, can you see? What is the path difference this time? See, the crest is matching, the trough is matching with this crest is matching with this one, so we'll get it destructive, they will cancel out. And why that is happening? There is no path difference? No, there is a path difference, but how much? So if this is lambda, okay, full step of a wave, so this will be lambda by 2. That is why That is why we are getting destructive interference because the path difference is lambda by 2. The same on the other side. What will be the next? Will it be 2 lambda by 2? No, the odd numbers. So it will be 3 lambda by 2. So here, if you see the dark spot will come when the path difference is 3 lambda by 2. So this is what we should know.